And so if we take a segment right here and you want to bisect it, the only thing you need to do is highlight the segment, just select it, Control M is the shortcut, finds the midpoint, and there you're done. If it asks you to bisect it with a ray, you simply turn it into a ray. If it asks you to bisect it with a line, just pass a line through that midpoint. If it asks you to construct a perpendicular bisector, again, all you need to do is select the midpoint, because you know the perpendicular bisector passes through that point. Select the line that it needs to be perpendicular to, and if you go to construct, you can construct a perpendicular through that, and again, you see it'll stay consistent. It'll always be the perpendicular bisector no matter how you adjust your segment. Okay? So that's what I want you to do. You don't need to show and leave markings like you would if you were doing this by hand. Okay, what if we were doing an angle bisector? So let's say we wanted to bisect this angle formed right here. If we just highlight the 3 points that represent the angle, click construct and choose angle bisector, you now get that value. So I'll turn it red here. So this is an angle bisector. Once again, if we adjust the angle, it'll always maintain its bisecting property. Okay. All right, so in addition to the bisecting that was in section 2.3, okay, there's also the constructions regarding the perpendicular. So we already did the perpendicular bisector. Okay, so let's talk about some of the other perpendiculars. So if we wanted to construct a perpendicular through a point that's on the line, again, if you just highlight the point, select the line that you want your perpendicular to be in its relationship, go to construct and choose perpendicular line, and you'll get your value. Okay, I'll turn that one light blue. Okay, if we wanted a perpendicular through a point not on a line, exact same thing. Just highlight your point, highlight the line that you want it perpendicular to, construct, and choose perpendicular line. And once again, no matter where you move this, that will maintain the relationship of perpendicular. Okay, as far as parallel, if you wanted to construct a line that's parallel to a given line, so let's say we take this red line and we want a line that's parallel to it that passes through this point that I just plotted here. If we highlight the point, highlight the line, once again, just like we did with perpendiculars, except now we construct a parallel line, we get a new line that is parallel to that one. Again, I'll turn it orange here. So these two lines are parallel to each other. And no matter where we adjust it, it'll always keep that parallel relationship. All right, the last thing that I want to talk about here is finding slopes. And so if you needed to find and identify what's the relationship between the slopes of two parallel lines, well, if you just highlight these two lines and click on measure and find slopes, again, it'll turn it into the grid problem for you, but it identifies right here the slopes of those two lines are equal. Again, no matter how you adjust it, those slopes will always stay the same. Oops. Right, the same is true for perpendiculars. If I wanted to find what's the relationship between the slope of this line and this line, these perpendiculars, and the way that you can represent that is to simply highlight the two segments or lines, click on measure, choose slopes, and if you computed the math on this, again, if we went into the number, choose calculate, and you can see, is it true that if we take the reciprocal of this, so if we take a -1 divided by this slope, do we get the measure of slope AB? And you can see here, again, as we adjust this value, that will always stay true. The negative reciprocal, -1 over the slope of line L, is always going to equal the slope of that perpendicular, again, confirming the relationship that we identified in class.